So you've been given a function and you want to rotate it about some axis or line or whatever, and you want to know what method should you use. Do you use the shell method or the disk or the washer? What do you do? Well, the way I see it, we have basically just four possibilities. Let's start with the most common. If I have y equals some function of x, the key here is it's solved for y, like y equals x squared. And say we rotate it about the line y equals a, like y equals 1, or maybe the x-axis, which is actually y equals 0. Well, if this is the case, this is either a disk or a washer method. Well, what if we don't have that? What if we still have y equals f of x, but we're rotating against y instead of y equals a? Now, let's say we're rotating against x equals a. Well, that means we're going to have to use a different method. We can't use the disk and washer. Instead, we're going to use the shell method. Okay, there's two more possibilities. These are the ones that I honestly don't like as much. They're a little harder to think of. That's basically if you have it solved for x. So if x is a function of y. Well, if you have x as a function of y, and you're rotating about x is some number, like say the y-axis, well, this is going to be another example of the disk or washer method. And then the final method, the final possibility, is if you have it solved for x equals some function of y. And if you have, this time, you're going to rotate against y is equal to a. For example, the x-axis. Well, in this case, you're going to again use the shell method. Now, what if you are given, say, y equals f of x, or x equals f of y, or whatever, and you want to switch it? Well, if you're given x equals a function of y, you could always solve it for y equals some function of x, right? So you could switch methods by changing the equation, what the equation is solved for. But otherwise, you're pretty much set by one of these four methods based on the direction of the line you're rotating against, horizontal or vertical, as well as what is the function solved for.